Raiders of the Lost Ark moment here, guys. I've got something over here in this box, that little project I worked on about 10 years ago. Came across it, and I thought it'd be fun to have a look. Let's go ahead. So, it's been about 10, maybe even 15 years since I put this project away. Let's go ahead and take it back out. So let me tell you how this thing in front of you got started. After I graduated, I used to go to the bar with my buddy Dave after work. We'd have a few beers and try to come up with product ideas. And this is one of those ideas. A wet diaper sensor. Let me walk you through it. Over here, we have a whole pile of capacitive sensors that we etched. We were trying to figure out which structure gave us the biggest change in capacitance whenever we had a wet diaper. And next to that is the syringe we'd fill with varying amounts of water, and we'd empty that water into this tube that drains out the bottom of this silicone torso, which would be wearing a diaper, and over that diaper we'd have these snazzy underpants made out of the cheapest spandex money could buy. The key feature of these underpants being that we have a pouch here which would hold the sensor. And finally, the sensor would go back to this processor board, which would read the change in capacitance. And so what I'm going to do for you now is rig all this up so you can see it in action. So this is the setup Dave and I would use to test our wet diaper sensor. You can see over here our silicone model is now wearing a diaper underneath his spandex. And we've got the evaluation board over here with the sensor connected. We'll put that sensor in the pouch in the bottom of the spandex in just a second. But over here, we've got the software for the evaluation board running. And as I touch the sensor, you can see that the green light turns on and we have some activity. So again, all I'm doing here is just touching the sensor. What we're going to do now is we're going to go ahead and fill up that syringe and test this thing out. So we now have the syringe filled with 15 milliliters or 1 tablespoon of water, whichever you prefer. This should be fairly accurate because babies don't have very large bladders. Let's see what happens as we push the plunger. So now we see why we shelved this project. As we add the water, there's possibly a very slight increase in capacitance, but not enough to reliably and consistently detect the presence of water. So let's see what happens when we use a cloth diaper. So this is the cloth diaper we'll be using. It has a blended cotton insert, and the fabric diaper cover has got a waterproofed interior. We'll be putting these two items together, placing them back on our torso, and running the test again. Let's see how the results change. So we've got the test set up again. We've got our water ready to go. We've got our sensor ready to go. And the torso is ready to go, this time wearing the cloth diaper. So let's go ahead and see what happens whenever we add the water. You'll notice that we've changed the scale to make it easier to read. And as we add the water here, we can see that we are getting a slight increase in the capacitance, up from that 0.7, 0.75 range to 0.8. And again, that's not really enough of a change for us to be able to work with. Next, let's rearrange the setup and run one more test, and after that, we'll talk about what's going on. So to better demonstrate this, we've taken our torso, flipped it upside down, removed the stylish underpants, and now we're just going to take our sensor, being careful not to touch any of the conductive bits, press it on a wet area of the diaper, and then press it on a dry area of the diaper, and observe the difference in capacitance. So on the screen, we can see as I put it on a wet area, we get a larger spike here. I remove it, and then I go ahead and find a dry area. And we can see here the area that was wet, and over in this area, the area that was dry. So we are seeing a marginal increase, and again, we can see why we've decided to shelf this project. The small change in capacitance we see between the wet area of the diaper and the dry area of the diaper is just barely above the noise floor. So with different sensor orientations, different environments, etc., there's just not enough margin to be able to reliably detect whenever there's a wet sensor. But let's end on a win. We'll do one more test where everything works the way we imagined it would. All right, so we've set the test back up again. We've got the cloth diaper in place, except for this time we've removed the waterproof liner over here. We did this because just like whenever you're using your touchscreen with gloves on, it's preventing our sensor from getting a reading. So let's go ahead and push the plunger and see what happens this time. So as we push the plunger and wet the sensor, we can see that there's a much larger spike here. So we've removed the stylish underpants, and we can see right here an outline of where the diaper's been wet. We're just going to take our sensor and press it on there and a dry area again like we did before, just to see the difference in the readings. So as I press it on a dry area and then press it on the wet area, back to the dry, back to the wet, dry, wet, dry, wet, dry, we can see how we hoped the sensor was going to work. So let's talk about our sensor and why things aren't working out the way we hoped. You can see right here, this is the sensor structure that we chose. It mainly consists of these two plates right here. They form a capacitor. And when the processor board sends a signal through this cable here, it drives out a signal on one of the plates and onto the other, forming an electric field. With the electric field emanating from the structure, the idea was that we could press it on a dry area of the diaper, and as it was wet, the dielectric material, the dielectric constant of the material would change and give us a different reading of capacitance values for a wet versus dry. The problem we had, as was discussed with the waterproof membrane, the electric field would interact with the rubber and not actually the wet diaper behind it. So the rubberized material didn't have a change in dielectric constant, and the capacitor didn't notice a difference. Similarly, when we used a regular diaper, the dielectric constant of the structure didn't change. We believe this is because the gel material inside the diaper, whenever it was wet, needed a lot more water before it would make an appreciable change in the dielectric constant of the gel inside. And so we didn't see a noticeable change in the readings. If we would have saturated the diaper with an unreasonable amount of water, it's possible we would have seen something. I hope you liked this video. Please don't forget to like and subscribe, and check out our website. We've got more information on this project up there, including more background information on the project, as well as some discussion about the different options for capacitive sensors.